Please do the needful.
Although I'm recording the session, if anyone wants, I can share that as well.
Okay, okay. Thank you. Thank you. Okay, Ash, please start.
Sure. So I'm just sharing this thing. I hope I'm able. Yeah. So in this session, we shall be focusing on the software setup and the basics of image processing through line demonstration. So first of all, starting up with the software installation. It's quite simple process. So whenever we will apply for evaluation license, we will be getting this particular software library for us to download and install the software. So the particular file that has application written over here, we shall right click over here and then follow thing by one as administrator command. We just need to click on yes, clicking on next. Here for the trial license, you need to provide us new site, and since I have a efficiency, so I'll keep my site ID as it is. Clicking on next, 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 and we'll just start the installation. It hardly takes around 1 to 2 minutes to for the installation to be completed. Once the installation is completed, we move inside the software. We learn about the different tools that are being present. Also, once the software installation is completed, we do one more thing. We set out the auto segmentation plugins. So, as I had discussed in the earlier session, how to install different plugins that are present like total segmenter, dental segmenter, unit models for doing the segmentation. So, after this process gets completed, we shall be getting on to that part. Just give it a couple of minutes for the process to complete. You can also see the files that have been installed. These are all the organic files that get installed one by one. Let me open the system. So it's going to be completed very soon. Once this installation is completed, we shall be moving on to the tutorial guide also. I shall be navigating how to work around the software using the tutorial guide because generally that's the best way to learn about any new software to get a familiarization with the different tools that are there in the software to get the knowledge about the algorithms that are being used while you are working on the software. So that's the best way to learn about any new tool. Also, the tutorial guide that we get in Simpleware is an intuitive tutorial guide that also has GUI level explanation. So even if we need to learn about new features, we can directly click on the question mark sign that we would be getting corresponding to each and every tool that is being present and learn about the software in the easiest way. Yeah, so as you can see, the software got installed and we get a pop-up window of do you want to icons on your desktop, we will just press on yes. So we will get a shortcut key to directly work on Simpleware. Once we get it, we just need to double click on the software and within fraction of seconds, the software gets opened up. Whenever we are navigating around the tool, so it's very important to understand what's the functionality of each and every tool, because once we are familiar with the functionalities, so for example, if some courses are not possible directly, we can navigate through indirect ways around the software to uh, work for our specific set of work. This being said, once the software is open, the software main window is divided into three sections. The first one being the project information tab that will carry on all the image information that we will be working. So, for example, if I'll be bringing in any DICOM data set, its image extent value, spacing between the pin slices, the total physical extent, that is physical dimension of the images, the total volume count, if we are importing multiple surfaces, so how many surfaces are there? If we are importing any volume mesh, what's the data set memory size requirement of volume mesh? All data gets recorded over here. This is the import section that we can work on, starting up with the DICOM images, where we can import any CT image, micro CT image, or an MRI image. So, for example, to work, we just need to click over here. Then we need to click on scan folder. Now we need to search for the particular folder that might be carrying our CT data set. So let us take this folder for example. Selecting this particular folder will load us our data set. So this is a CT of enjothorax region, where the total number of slices that are being present are total 372 slices. So we can also navigate around this slider to check how the data gets varied in the actual view, ranging from the 0th slice to the all the way to 372 slice. Also, the patient information, which was the machine from which the particular city was taken from, what was the dilution rate when the city was taken from, all gets visible from here. Then we have an option of minimizing the type of data types to basically store important information and which we need not to share with any researcher. So we can minimize any type of data types that is required. Apart from it, since we are dealing with image processing, so there is one more important tab that many users don't generally follow, is this advanced import option. This advanced import option plays a very crucial role when we are redefining any boundaries or we are changing the region. So, if we have a large number of data sets, it is quite difficult to basically print in software. What we can do is we can either crop the data set or else we can also do pixel rescaling. So here we will need a particular pixel rescaling. We can select a particular preset also. For example, this being a hard CP dataset, so we can select out any soft PC to mark the boundaries accordingly. Or else we can also use a DICOM window in level 2 to identify the different region, or we can set out our preset value over here. So for example, if I set out a window level around 700, 770, and the level being around 20. So we can see the color change, and once it is done, we can click on finish to load the dataset. But for general medical dataset cases, it is not required, because you can see the initial memory size that the data requires is 26 MB. And generally to process any dataset, it is only 8 times the RAM size or dataset size memory is required to process the dataset. So we can uncheck this window, clicking on finish will load our window in three views, being coronal view, then we get the sagittal view, and then we get the axial view. Here we get the particular position also, the anterior, posterior, superior, inferior, and left, right, and lateral position that we get in over here. Apart from apart from that, we also get the volume rendering of whatever data set that we are working on. Volume rendering also plays a crucial role while we are segmenting out. because here we can see different parts directly, and if we are able to identify different parts in a very easy way, so it will ultimately help us in further, after the segmentation is performed, to split the region into various parts. For example, through this volume rendering only we can see that this is aorta, this is the right atrium, this is the left ventricle, this is being the right ventricle, this being the right atrium, left atrium, and then this being the pulmonary vein. So every part is easily distinguishable over here. Why so? Because we have certain background volume rendering settings that we can use for easier visualization. We can either manipulate it manually, or we can automate this particular process. How? We can increase or decrease the dimension. We can manipulate over the HCV value, the color value that we require. So we can also manipulate the color coding. Apart from that, we are also given the various sets of presets to be used for. This being a cardiac set, so we can use a cardiac preset, so to highlight the different cardiac regions that are being designed. Or else, a better option for such data set is to use a AAA preset, so that we can have a clear region identification. How this works is, it works on the grayscale value that the image has the coding of. To check what is the grayscale range of the dataset, we go generally in the image processing. In the thresholding, we can check that the lowest grayscale value is -1024 and the upper grayscale region is around 2290. So this way we can get a quick overview about the grayscale rating of this dataset. Let me open in another window. So at a time, one user can use on multiple windows in a single system. So this was how we can import any Nikon dataset. If we are having any industrial images, so we can use this Nikon images option. We can go in the scanning folder, and then we can select out the files that we need to work on. Then we have this back server connectivity, where we need to set the particular private key and public key. If it's a password protected, so we need to set it accordingly. And then we can directly connect with the back server from here and directly import the dataset in our working window. Then we also have the stack and raw images. So even if we are working on any raw data set, if we need to do surface editing, that can be done too. We can do the PMP images, PPT, PPT, PMP, PIFF, any raw image file, volume file can be imported. So we need the modality, and we do have the support over here in the software range. Then we come on to the 3D image formats that are being supported. The first one format that we start with is the analyze. So any analyze.html file can be imported. Interfile can also be imported out. Then meta images also play a crucial role while we are working on any 3D models directly. If we need to import any human body model project, which is very efficient while we are marking the biomechanics calculation. So we can also import .html files. And last but not the least is the Nifty images support. This means that apart from this, we also have the support of any STL and CAT file. So we can import the particular file as .stl, .ply, .ijs, or the stuff like that. So these are all the particular file formats being supported. And then we have this volume mesh file to be imported. So if we are having a CDP file, a INP file, a NestRun, or BTK file, we can import the particular files from it. Once this is done, uh, if we are working on any specific project and we need to open it directly, or if any other user has worked on certain file, so we also have an option of .sip file, that stands for scanip project file, through which we can import the dataset from here, and whatever project that we are working can directly be loaded in our code. So this is one such option. Then we also have a dedicated tutorial guide in which we can understand the software through its thorough means. So what we can do is, we can go in the help and support section. Here we have a tutorial guide option. In this tutorial guide, what we need to do is, we need to click over here, load the field help topic and external web stuff. And once we click over here, what it would do is, it will open us the detailed tutorial library. We can switch in mode from dark theme, light theme, whichever is preferential for our viewing perspective. And now to learn about the tool from starting, what we can do is, it has segmented the particular different tools depending on the nature. So depending on from easy to general overview to the 3D printing application, materials industrial application, and the general, all are being measured over here, and we can just directly start from this medical imaging part. Here, this tutorial also tells us corresponding to which folder the particular file is stored. So as I had mentioned in the earlier on session that we provide the example data set with Simpleware. So you can check over here from when we go inside the C folder, inside program files, we have the Synopsys. So when we will be keeping the default folder during the installation procedure, we can directly navigate to this particular folder file to check for our data set. Once we do the particular import of data, it will also, the particular module also tells us the different operations that we would be learning in the software, like DICOM import and resampling and cropping, threshold based segmentation, and PET value of segmentation. So in this tutorial, it navigates that first we will be checking how to import the DICOM data set, and it's done the simplest way. So as I had shown, we can click on the DICOM files option. New project, we can scan the particular folder, then we select the proximal P1, and then directly clicking on finish, it will load our file in our navigating view. Now, coming back to the window. So I'll be just navigating through both tutorial guides side by side, the window in which we will be operating. So anyone can have a greater clarity. This particular data that you are seeing of me is a knee MRI data set. One might ask that how I get to know that it is a knee MRI. So there are two options through which we get. First of all, when we'll go in the DICOM text option, so in the home, we'll click on DICOM data text, and we can see this is an MR dataset, which is magnetic resonance imaging dataset. And the earlier dataset that we were working, this heart was a CT dataset that we can check from here, DICOM dataset CT. So this is one such thing. And the positioning and the views naming is different from CT to MRI. So that is also another way that we can identify the different views. How to do that? We can go over here in the knee MRI section. We can learn that if we need to have the PD view, we need to keep the coronal and sagittal as a single view. For T1 and T2, the calcium calcium, we can to have coronal view, sagittal view. But you will see that when we are dealing with knee MRI or any other MRI that we are working on, for one view it is very clear. We can easily visualize different soft tissues. We can have easier identification between soft tissues and hard tissues that are present. Even small nerves are visible very clearly. But when we are considering other views, it's not that clear. So this is generally the case with an MRI dataset, and it is generally recommended when we need to develop a very accurate and highly efficient model. If we have a patient data set that is containing both CT and both MRI, then we will be developing the highest quality of the model. What we need to do in that case is we will do the image registration, and then we can import the particular file over here. And once we do the particular fusion of images, we can have the most accurate segmentation to be performed. Now, taking the example of this heart only. Now we will also be seeing there is one more tab that tells us data browser. Then we have the slice selector, so we can navigate between the slices. So we have multiple options. We need to slide through the slices, and we can see that when we are slicing, so the particular corresponding to action view, the slice is clearly visible in the coronal view and the sagittal view. Apart from that, when we are working over here, we can again navigate through, and we can work on any specific point. For example, if I need to click over this point which joins the aorta with right ventricle, what I'll do, I'll just click on left click in my mouse, followed by P keystroke, and you will see that automatically it has shifted the points of movement in all the three views, coronal, sagittal, and axial, to the specific point that I was referring to. So this way the point identification can be very easy when we are working in Simpleware. We can click on any point and we can see in all the slices it navigates through the slices to the exact point that you are working with. For example, currently we are in 31st slice in the coronal view. Now if I click over here, so we have moved on to the 53rd slice in 467 in the Sagittal and 169 slice in the axial view to the specific point that I had marked. This is the easiest way to navigate between the slices to know the exact coordinate values of the particular point. How to do that? When we will be hovering on any point in any of the 2D views, you will be seeing that I am getting four values. So the four values basically correspond to x coordinate followed by the y coordinate, then followed by the z coordinate. And over the pattern section, the K49 corresponds to the specific grayscale value to the point that you are working. This is the most important step to learn. Why? Because once we are familiarized with the coordinate position, when we are familiarized with the grayscale range, so if we are dealing with any biomechanics application like bringing an implant, it plays the most crucial role to place the implants accordingly. We also have custom coordinate systems at data site. We are having multiple images. We need to align over one another. That can be done quickly. Apart from it, we also have a 4D frame toolbox. So if we are having a 4D data set, so we can check over here. One might be wondering how this particular 4D data set looks like. I do have the file. Either I'll show you at the end of this session or in the cardiovascular session that we'll be covering on day 4. In that also I can, my colleague Pratik will be showing the 4D, how to navigate through the 4D data set. So this is one such important feature that we can work on. So this is just to visualize the data set that you're working on to get familiarized with the CT MRI. One more such tool is if we are since we are generally familiarized with the 2D views. So we also have a virtual X-ray generation wherein we can change the opacity accordingly. We can change the orientation from coronal, sagittal, axial, and corresponding to each orientation we can set out the grayscale range. This way it allows us to set out the virtual X-ray generation. Here we can also set in the particular views that is being required. So if we require a particular sagittal view, we need the orientation also, so we can mark up accordingly. And once that is marked up, one more feature that we get is we can have an object burn-in. So once we have done the segmentation, if we have identified different regions, we can burn that region out. And by burning, what I mean is if I have segmented the aorta out from my rest of the part. So when I will burn the particular object, the particular part gets highlighted out, and we can focus on the specific region. Now, so uh, moving on to the next part is the image processing. Coming on to the image processing, since this workshop, this particular session is focused on image processing. Here we have the transforming operations, then we are followed by the segmentation, and then we have the additional filters that we can work on. Coming on to the particular resampling operator, here what we can do is we can just navigate over here. You can see currently the particular values that is 0.7012, 0.7012, and 0.7. One might be wondering what are these values. So if you aren't familiarized with this particular range, let me simplify it. It is nothing just the sampling space between two corresponding slices. So it tells that the distance between the particular one slice to another slice in the coronal view is 0.7012. The spacing between the two slices in the sagittal view being 0.7012 and the spacing between the slices in the axial view being zero point 0.7. It may vary depending on data set to data set, and generally a recommended value is between zero point 0.5 to 1. If we are having a value close to zero point 0.5, it will generally produce high accuracy. Why so? So when we are doing the resampling, either we can upsample the data set or we can downsample the data set. But for medical data set, if we are sufficient with the memory, if our hardware is good enough, we might not rely on downsampling the data set. We might upsample the data set if required. So to show that, let me just bring in how it will do the particular changes. So opening this particular window, bringing the console, selecting the file that I was working with. Yeah. So to do that, to showcase the change that gets occurred, one more option that we get is whenever we will right click over here, we'll get multiple options. So if we are combining different DICOMs, if we need to export it as a DICOM dataset, that can be done. If we need to duplicate the dataset, what we'll do is we'll click on duplicate and it will create as a copy of the DICOM. Now, if we are doing changes in this particular copy and we need to keep the original as it is to check for the accuracy later on, we can do that. We can work on the copy of the DICOM dataset. And one more thing that you might see getting buried is earlier on the dataset memory size required was 26 MB and now it is 52 MB. So it has doubled down. So it was 26.04 and now it has been doubled down to 52.08 MB. So whenever we will be working on such operations, it will hamper our memory size. And whenever we will be creating multiple masks, whenever we will be creating on multiple methods, it can be worked on too. Now, bringing on to the resampling operation, coming back to the resampling operation. Now, since this is the particular active diagram that is selected, what we need to do is we can set out the value. For example, I am just having down this value and in the integer superior position, I will just mark this down. Now, just check. Currently, the number of slices in the coronal view are 199. The number of slices in the sagittal view are 174. So it's 175 because we have started from 0 to 174. So the total number of slices in the sagittal view being 175. Similarly, in the axial view, we have started from 0 all the way to 371. So the total number of slices being 371. This way, we get an approximation of the slices. Now, since I have up down this value, so any guesses in mind that will it upsample the data set or downsample? So let me tell the answer. It will basically upsample data set. How? Once we will click on apply, so it will reduce down the slice thickness. So earlier on, the slices were 200 and now the slices are 400. We have just doubled down the values over here. Similarly, we have doubled down the values over here and in this place. So this way, we can upsample the data set so we can have a better visualization of the same data set. Because earlier on, this particular was divided into single slice and now the particular same operation is has a much more better clarity in the next slice view. So in the medical cases, we can definitely upsample the data set to have a better clarity. Now, this was one such operation that we considered under pre-processing section. Now we have the other operation being the cropping. In cropping, for example, if I'm just working on this hard part and I need to crop it down from the top view to the bottom view, what I can do is either I can crop it over here and whatever modifications that we would be doing in one view will get reflected in other views too and in the 3D also. So even if we are cutting down the value in the 3D, so we can see that particular changes being done in the 2D view. So in whatever view we are required, we can do the particular changes. Also, once we have done this, once we have done the particular modification of the data set, now rescaling option is generally not recommended for medical data set because it distorts the physical dimension and it won't keep the accuracy of the data set as it is. Then we have the sync wrapping option. So if we are bringing in any STL file, CAD file, we can bring the particular file over here. And if we need to increase the spacing, so we can do the same over here in our view. Then we have the sync wrapping option. Then we have this padding option. So if we need to increase the pad size, that can be done. Padding I can show here how we do that. If we increase the padding by 10 units in all the times, I have taken 10 so that there's a easy visualization of this. Then I will click on padding. So you can see there is a dimension change. It has increased the uniformity across all the particular directions. So one might ask why we have done this because in the earlier step we were cropping and in this step we are basically increasing the actual spacing, and it also hampers the data set memory. It increases the memory size. So I'll just undo this. I have undo that particular task. But why we do this type of padding? For example, if we are bringing in any plant and it is not getting occupied in my current view. So the easiest option is to increase the padding size in any of the view that is required. We just need to uncheck this uniform padding. And for example, we can increase in the right or left pixels and all settings is 0. Now you will see only in the left right view, I'll get the particular dimension increase and all the other views get as it is. So for example, if I was working on any femur part, right femur, left femur, we can just bring the implant as it is and cover out in our window of working. Now, moving on to the next part, being the aligning operation, that generally is not required for any CPMRI as it generally depends on changing the orientation around the axis of the data set. Then we have the flip operation. We can flip the data set around the any axis. It is generally used for mirroring operations so that we copy the data set, we mirror the data set. So these are some advanced options that is that any user can use, but for now, if we don't use them, it won't be causing problems. So if we need to learn about any tool, the important feature that we have in Simpleware is we have a question mark sign corresponding to each and every tool. Where we go over here, we open the window over here and we can check how and which operation will it be doing while using any specific feature. So corresponding to any tool we can learn from here. Now coming on to the basics of segmentation. Segmentation is quite important case while we are working on any part. For example, considering this data set only, if we're only considerate of the aorta and we need to mark the aorta and we don't require any other region. If I would be going through a conventional approach, what I have done, I might have selected a paint operation, clicking on into slice, and then selecting in this slice, we would have marked the region. So to do that, we can mark over here, and then we need to basically paint. So I'll just increase the size, reduce the brush size a little bit more. Yeah, for example, just being a menu location. Now, the most difficult part in this type of operation is we have worked on one slice, we have taken a new axial view, we have worked on zeroth slice. So when it would be doing the mapping, so it will be considering only the zeroth slice of the axial view while it would be generating a mask. Now, similar to that, once we have done on zero, we can control the slices through the cursor in our mouse. So we can navigate between the slices from our mouse itself using the cursor. So scroller that we have in mouse. So we need to mark the region in every view that we can see the particular part. Any user will get frustrated using this process and might think that it's a very lengthy and cumbersome process. So to ease that part out, what we have is we have a better option. So you can see I was manually marking in each and every view and slightly it was building up the shape. And in this cases, we need to be very familiar with the data set, the CT that we are working on. We need to be very familiar with the anatomy that we are working on because it is important while we are working on each and every slice. So this is one such operation. So now we have applied this operation in Excel view. Similar operation we need to apply in the coronal view. Same is to be followed in the sagittal view, and it will take around 10 hours, 12 hours just to mark out a single region. A better approach being a paint with threshold we mark the region. So this was the most primitive one that was used in the initial phases of medical image processing way back in 1996, 1999. Then came up the approach of paint with threshold. It was introduced around 2005, how to use a different set of segmentation techniques. Here we selected our threshold range, marking it from the histogram that we can see. And once this was done, we still had to work on each and every slices individually and mark the region. Then came in an approach around 2007 to threshold being used widely. So the timeline that I'm mentioning is the widely used case of the particular different region that we had. And it was valid till around 2015. So people rely now also if you'll come across any user of any tool, image processing tool, he may be familiar with the threshold increase because it is still quite popular. Now we have other approaches, but this was the earlier approach that we used to have. So in the threshold link, in Simpleware, we have provided three different modes of operation just for the thresholding purpose. So even if we don't work with the uh, tool range, what we can do is we can select any preset to mark the region. And earlier on, what task was required to do in couple of tens of hours got reduced down to a couple of minutes. We just click on the fill cavities in the resulting mask and only keep the largest resulting value to remove our finger uses. Once you will click on apply, we'll get a tentative mask. Why I say tentative is because it will also include the orthopedic region. It will also include small noises that are still present in the data set. So I'm just deverifying it, and we can see it is missing certain regions. It is missing whole of right ventricle, whole of right atrium. But still, if someone wants to work on aorta, he can easily identify this and distinguish it out from the rest of the structure. So this way, it has driven down the time of computation by a significant margin. But still, it is still a time-taking process because it has done the initial splitting. Now, what we need to do is we need to split out those particular parts into different regions. To do that, we go over to the split region operation. Here we click on the preset. Since this being the heart, I can select it over here, and then we need to mark out the boundaries accordingly. Now, I shall be taking a much more easier example to show this because whenever you are working with Simpleware, generally a heart may be a difficult option to get started with Simpleware software. So instead, I shall be using an ankle data set that's much more easier to understand the software. I'll be opening a new window. Here, to open the data set, I need to go to the Open Project section. In this, the data set that we have, please keep this in mind. We had in the C folder, we need to navigate in the program files. In the program files, we need to again re-navigate into the Synopsys, Simpleware Medical, version X 2025.06. Then in the dataset, we have this sample city l.sip file that we can directly open. Now, hard segmentation is quite tough, so that's why we have kept it for day 4. So once we get familiarized with the basic segmentation and orthopedics and general segmentation, we can move on to the hard segmentation. Before that, this is a foot and ankle CT data set that we are having. Whenever we are working with any image modeling, it's almost the same, right? Identical. So we have the same base coordinates, other connection. We can still navigate through this volume rendering of the data set. And this is the this is the best option that we have in Simpleware. When you will be going and working across different softwares that have the volume rendering option, they don't have this much clarity in the volume rendering. And ultimately, when we need to overlap to check for the accuracy of the segmented path, this plays a quite crucial role. Apart from that, we also have the 3D clipping. So if we need directly clip in within the dataset itself, so we can clip in, we can see the new features also. Then we can rotate it along the control axis just by pressing control and followed by left button in my mouse. I can rotate it along a central view. I can realign the structure in any view of my liking. Just it's a very easy process to align my view. So shifting view, just realigning one direction to view it more clearly. You can use a bone preset to visualize the bone part that is being preset, and we can directly see the clipping and the internal structure. So even if any initial needs to understand about the animal or any new user needs to understand the environment, this is the best approach that I can recommend. So we can clip in the different region. We have different slice and plane setup that we can work across. We can set our own set of plane along which we need to put the particular image data set that we are working. Then if we need to export it in a VRME view, that too can be done. There are multiple options that we have. Coming back to the thresholding operation that we were discussing on. So here, as discussed, we have three modes of approach. Either we can use a threshold. Here we can check in the 2D views how it is marking the region. And once the particular region has been marked, we can click on this fill cavities and clicking on apply, it will bring out my region. But you can see there are noises that are being present. So we have three modes of operation to remove out the noises of the disconnected region. What we can do is we can go in the mask split fill section. Here clicking on the operation as split fill followed by the mode as 3D and clicking on update 3D view on the fly. Why we have selected this option, we need not to again generate a fast preview as it will get out, out of it. So now to apply the operation, I'll just click on any part and you will see in a fraction of seconds the disconnected parts got removed. This way, it's very easy to work on this data set and then we can mark out the different region. We can go into the split region tool. In this split region, we can mark it individually. So we have two modes of splitting the parts. Either we can mark up the boundaries in the 2D views, we can just type in the markers over here and then we can just mark up the boundaries like this. But I generally recommend to use a 3D view to mark the boundaries because it provides us with a better approach. Also, the output that you will getting is generally a better output. So to mark up the boundary in a faster way, I just click on this light 3D and once it is changes the sign from blue to golden, we can start marking the boundaries in the 3D view. To do that, we just need to highlight the region. We need not to go into detail about the marking. Just we need to tell the software that these are the boundaries that it needs to consider while doing the segmentation. And later on, further modifications can be carried out. So, like this, we'll just mark the region from here. So, we will be segmenting the tibia from fibula. So, here, mark the tibia, fibula over here, and over here, because this part is extremely important while we are marking the region. Always mark the boundaries properly because the with, yeah, there is no question. So whenever we are marking the particular boundaries over here, what we need to do is we need to take in consideration the region in which two different parts are getting separated out. Similarly, we need to have this ankle board. I'll click over here, mark it accordingly. And generally, we can look for any skeletal system or any images from web to mark the regions in a very precise way. Once we have done, and we'll keep our focus in separate one entities within this mark. So this I have shown in a very brief way, but when we are working and when we get some familiarized with the software, we can use this operation in a much more detailed way. Now to check a general preview how the particular software is marked the different regions, I can just click on the fast preview option to generate a preview of the same. And once we have generated a preview, we can check how it has identified the different regions. So if it has marked some boundaries of the foot region with the ankle, what we can do is we can again mark the boundaries over here, marking the different regions. So it gets separated out. So preview is a very good option when we are working on a new data. Once we are done, we are satisfied with the effect, we can click on apply and then we need to click on this generate a fast preview once we have done this splitting operations. Now, for example, we have marked this region and if we are only interested in this CBR. So what we'll do is, in a few minutes, what we'll do is, we will click over here, we can isolate this particular part out, and then we can work on it individually. So one more option that we have is, we have this enabling of background volume blending while we're working with data. So whenever we will be clicking this option, since this mask is already open, what we will get is, we can check over here, we can navigate, we can check for the accuracy whether all the particular regions are being marked properly or not. And once we are satisfied with the surface, then we can move on to the further part. Once this is done, we can rename it whichever is required. So I'll just rename this T1. I can also change the color, the opacity if required. So since this will support, disable this volume rendering because I need to work on this specific region. And once we have selected this part, we move on to some other features that we have. For example, if I need to use some 3D editing tools, this 3D editing tools plays a vital and crucial role. We'll get to understand this in the upcoming sessions tomorrow and after tomorrow, why these tools play a crucial role. Just to brief about what are the different tools that are present in the 3D editing section. We need to just click on this 3D editing option. Once we have clicked over here, we can set out the different operations that we can use. So the operations that we get is the delete operation, the smooth, dilate, erode, open, close, and local surface colors. So to learn about this tool in a detail, you can go over here in the question mark sign. And these are how the different operations will work and how modifications will take place. What are the changes that we would be observing? This is the best way to learn about it. But just to give up overview, for example, if I am using a delete operation and I am selecting this part out that I don't require this part, so I can either use a lasso that is a freehand operation and it will automatically delete the selected part from the remaining part that we were having. And we'll just undo this operation to showcase other operations. So if I click on this smooth operation, for example, this is the region that I need to smooth out. I can either select this rectangle option, and for the rectangle that we have selected, we'll smooth that out. Either we can again select the lasso operation, selecting the part that we need to smooth out. Whatever pixel strength that you would be selecting, ranging from 1 to 5, we can select and it will smooth out the surface accordingly. Why we generally are not using this for smooth operation, dilate, erode, open flow? Because we have a separate tab for that. So whenever we will go over here, we have a much more detailed and overview of tools over here. So this is a better approach whenever we are using various sets of operations. And these operations play a crucial role when we are basically dilating the feature. For example, if we need to develop a hollow model or a hollow structure, dilate plays a crucial role. We just copy a particular file from this mask using the dilate feature. Then we use certain Boolean operation to remove out the region. So this is how the 3D editing tool basically works. We can use any operation, smoothing, direct, open basically moves 2 pixels away by the any pixel strength that we select between 1 to 5. Close brings the pixels together. So let me show over here for the same part. If I select it over here, you can see actually this particular result won't get very much visualized over here. A better approach is, let me select the point just over here. I'll just click on left click in my mouse followed by T key stroke and keyboard and we'll go to the specific point. Now for example, I'll just go into the specific view. Yeah, just like when I send you a message in the chat box, what I'll do is just let this session get over. After 3:30, I'll guide you how to do the registration to apply for the valuation copy. That's it. Yeah. I'll help you out with the installation procedure, how to do this. Let's not even just after your session, uh, you can just communicate with me. You can contact me over my WhatsApp. Uh, I'll just help you out in this. I've also texted my contact detail in the chat box. So coming back to this particular close operation, open operation. So since I was discussing, if I need to apply the operation over here, first I will go to the specific point. Now, if I am bringing the pixel strength around 3 pixels for the specific region, now we will be seeing the counter level change slightly when we have done this. So whenever we will be doing this, so the counter region will get changed and we can visualize the result in the 2D and 3D view. This is very much applicable while we are dealing with any soft tissue, because when we are modeling soft tissues are the most difficult to segment out. Why? That will be covering in upcoming sessions, why the soft tissues play a crucial role while segmenting and why it is the most difficult part. Just to give a brief, whenever we are segmenting out any soft tissue, what it generally does is it also highlights the small uh, errors that are present in the data set. Also, it highlights any metal artifacts, any other artifacts that are present. It also gets overlapped with the orthopedic data set, that is bone parts or any muscular region that is present. So it's generally difficult to identify the region. But we have smart workflow for that too, to segment out different regions. Now these are the 3D editing options that we have. Next up is the advanced tool option. This advanced tool option, generally multi-level option segmentation is recommended for the material purposes, but we can also use that in medical image processing. If we are dealing with any magnetic resonance imaging MRI dataset, we can use this magnetic lasso to reduce out the noises. Apart from it, we are given you multiple advanced filters that we can work on. So we can work over here, we can do the city correction if required, we can do noise removal directly, we can do any segmentation, we can do the strength transition when we are working on central line network. That all gets covered in the measurement section, which will be featured in the day 30 of this workshop. Yeah. So here, uh, navigating through the image processing tools, we have the uh, smoothing filters. As mentioned in the presentation part, we have 5 types of smoothing filters. We have the recursive Gaussian, then we have mean filter, we have median filter, smart mask smoothing, and D-step filter. Why I prefer a recursive Gaussian and a smart mask smoothing is these two, smart mask smoothing doesn't distort the image dataset at all. So to preserve all the anatomical features as it is, it's the most easiest way. Then whenever we are using any recursive Gaussian, it is also recommended for medical purposes because it also won't distort the image dataset when we range out the value from 1 to 3. How? Whenever we will be hovering on this particular value, you will be seeing the description of the tool and a value that is to be recommended. So whenever we are generating a smooth mask for the same, it won't distort the image dataset. Once we have done this, if we need to smooth out this particular part, although we have already explained, but just to showcase how it actually works, by selecting out the target region as tip T1 that I have distinguished, clicking on apply, it will smooth the region. We just need to generate a fast payment and we can see it has smoothed out the particular part. It is generally used when we are working on any 3D printing part. When we are doing the 3D printing, it is generally recommended to smooth out the external features because it will reduce down any error possibility if so present. So we can use this approach. Also for the coming on to the 3D printing part, we have the bone filling option. Here we will be selecting input as T1, clicking on apply, will solidify the bone part. How it will solidify? Currently you can see there is a cavity within this bone. And if we are doing the 3D printing and if we don't require this 3D cavity that is being present, either we can use this cavity fill operation or else we can use the bone fill. Cavity fill will only fill the cavities that are smaller in value, that has a voxel count, that is volume pixel count around 27 voxel units. But this whole filling will work on the entire structure and solidify the whole in a single operation. We just need to click on apply and the process gets started. Once it is done, it will take some amount of time, around 1 minute, to the solidification of the code. But when the solidification is done, we can uh, cross verify the result in both the 3D view as well as in the 2D view. Yes, we can define that. We can define porosity for any specific region. But for that, what we need to do is first we need to develop a finite element model for this particular section. And once we have developed the particular finite element model, we can define the porosity. Or else, if we need to do direct porosity analysis, that too can be done. So let me show directly. We just need to drag and drop this selected part into analysis section, and we will get three sets of analysis: fiber analysis, particle analysis, and pore analysis. Although we can directly generate from the segmented part, but I generally recommend any user to use once we have done the FE modeling over here, then use this particular option. And the FE modeling will be told in the tomorrow's session how to do the FE model, how to generate the FE model, and how to basically we send the particular file for answers to do the simulation. To do a normal porosity analysis, we can generate that. Whatever part that we have selected, we can just drag and drop over here. And in the object section, we need to also drag and drop the diagram image corresponding to that we need to do. Then we set in the sensitivity value. So to select out the smallest size of the pores that are being analyzed, we can set it from here in the terms of voxel units. So we have taken 10 raised to the minus 6 millimeters of the particle value. So once it is done, we just need to click on the done analysis, and we'll get a statistical tab of the same over here. So we can see the total number of pore counts for this structure are 5, third count is 1. We can see over here all the particular volume corresponding to the total volume that it is occupying, all pore volume, surface area, volume fraction. Also, we have option of plotting the dataset that we are generally getting. So if we need to plot a pore volume histogram, we can check over here. We have multiple options in this plotting option that depending on our requirement we can select it over here, and then we can map out the region as required, how the particular diameter is changing. And we can also export this whole part as a CSV file or a text file if we require for a report to be generated. We have a separate reporting section. Then we will go, we can directly generate out the report from here. So core analytics and short analytics can be done in a complete way. So we were dealing with the image processing part. We have used a bone filling operation, and in the bone filling operation, we have solidified the particular bone part. Once it is done, we can generate a fast preview and we can see it has solidified the particular bone part, but it has generated some small regions that are present on the part. So to correct that out, we can use a local surface correction. We can apply the local surface correction to further remove out any smaller deformity over here. And for the section over here, we can use the 3D editing. And in the 3D editing, we will use a close followed by smoothing feature to further work on this specific part. Once it is done, we'll again click on smooth, and then we'll smooth out this particular feature. Now this is the easiest way to work on any part, and this is the best workflow for a basic image segmentation. Coming on in the next session tomorrow, we shall be working on the auto segmentation part for orthopedic section, and how we are doing any city segmentation, because it is the best example to learn about the segmentation. We will be also covering out the surface tool option in the day 3 when we will be moving on to measurement part. I'll also, apart from engineering perspective, I'll also show how any, although implant will be shown in the tomorrow session, but day after tomorrow, if there would be any doubts, I will be covering that too. Measurement will also be get corrected into day third and printing also. And all the analysis and all, we shall be covering out in the day 4. And for this session, there is one more important feature that I need to discuss. So I'll just take 5 or 10 more minutes to cover out my part and to show what are the extra features that we have in image processing. In the master statistic, this is the very essential tool from a researcher's perspective because we learn about the software in a detailed way, whatever properties that we have calculated, we can directly generate over here the total voxel count, the total triangulated volume that this particular region is occupying, surface area, the grayscale mean value, the standard deviation of the grayscale value. Also, in this template library, we can edit out the template according to our specific requirements. So, changing on the part by part, we can select out the region that is required, the different columns that we need to add. We can just select it over here. We can add the selected region. We can set out the value. This is a very detailed tool and it takes around 2 to 3 days to just know about this tool because uh, through by a researcher's perspective, it will play a crucial role because whenever we are saving out the report or we are exporting the particular statistical template, we can directly insert in our research paper. We need not to go through many updates by copy pasting the value. It will not do the task for us. So it is a very important tool. Apart from this, if we have developed a finite element model to check for porosity analysis, the mesh quality, orientation, surface quality, we can use this model statistic. In the measurement tool, when we are doing the center line network measurement, we can use the center line statistic. Also, this is one such feature that I really need to talk about is this log section. So whatever task that we have performed, right from the import of type-on data set to using the thresholding operation followed by cavity fill filter, all gets sorted in the log system. The best advantage that we have in Simpleware if you are having multiple data sets with a similar grayscale range, what we can do is we can select out the part for which we need to have the API creation. Once we have selected out this part, we can convert to a Python file or a C# file whichever is required. Once we do this, it will create a API script for us. We can just save it. We can just save the script as, for example, documentation. And later on, if we are having the same set of data set, we can directly use the particular scripting option and our API can be created. And to learn in detail how to create different sets of API, we can go over here, we can check out the class list. So if there is any coding enthusiast who wants to enable his set of presentation algorithm or need to know what are the advanced features that we can work on, we can definitely go in the scripting section to learn about the different tools that we practice. So this is just an overview of the basic image processing tools that we have in Simpleware. If anyone has any doubts till now, they can let me know. Even after this session, if anyone has any doubts, you can just put up a message or we can also cover the particular doubts in the new session, whichever is differential. I'm just also writing out my mail details so if anyone wants to send that over, they can send it over there. So the session is open for question answer. Kindly raise your queries if there are any.
Hi everyone. I just wanted to say that the demo was excellent and the software has a very has a lot of potential and the explanation was very well crystal clear. And I want to say this, that I understand that this is an advanced workshop, so having some basic knowledge in this field definitely helps with better understanding. For those already working in this domain, you will agree that such high quality demonstrations are often either hard to find or come at a significant cost, especially for researchers. So, this session is truly valuable. So, please pay attention to this. And a big thank you to your firm and to the participants also who are giving the active participation. And a special mention to Dr. Zamir because his thoughtful questions are really helping us exploring the topic in greater depth. So, and thank you, Ayush, for your
Thank you so
time.
much, Sakita.
And always, if you had any question, please drop a message.
I'll be providing the recording of the session, sir. Also, I'll be
I'm going
helping
to add you on